The first stars, the foundation of all we have today. From the screen you're watching this on, to the awkward tan you get at the beach, we have stars to thank. But what were the first stars? How did they form and what were they made of? It all started in the beginning.
The universe was in a hot, dense state that nearly 14 billion.
Not that Big Bang. That show sucks! It all started with the Big Bang. For the first hundreds of thousands of years, the universe was extremely hot. Too hot for stars or even atoms to form. So after millions of years, it cooled down, and particles clumped together to form hydrogen and helium, first as charged ions. But eventually, they would settle into neutral ions. Gravity from dark matter is what originally pulled in those neutral hydrogen and helium atoms, and eventually the clouds became so dense that they collapsed, and the atoms inside combined in nuclear fusion reactions, forming stars. Now, these stars were only made of hydrogen and helium because that's the only elements that were around. Stars now contain heavier elements such as carbon that have fused or were collected from older exploded stars. The first protostar is theorized to have a 1% mass in comparison to our Sun. Only 10,000 years later, 100 times our solar mass. At this time in the universe, everything moved at an accelerated pace. Because these stars only had hydrogen and helium, they were a lot larger and a lot hotter than the stars we can see today. Possibly 30 to 1,000 times the mass of our Sun and 15 times hotter than our Sun. These stars were so hot that they didn't really give off visible light. Instead, they gave off UV radiation and UV light, kind of like a giant black light. Within these first stars, over millions and millions of years, hydrogen and helium atoms would fuse together to form heavier elements. Then, the first supernovas would happen, flinging those heavier elements like carbon and oxygen into the universe, creating what we know today. Well, how do we know all this? After the Big Bang, radio waves were present in our universe. It was theorized that starlight may have excited the hydrogen gas and absorbed some of the radio waves. An antenna roughly 6.4 feet initially caught the readings. However, this reading was faint and difficult to listen to. Listening to this frequency was extremely difficult, and it was thought that it was not prominent or promising enough for a published finding. It seemed impossible, but in the Australian desert, the antenna averaged the frequency not from a fixed point, but across the entire sky. Over time, the sensors were fine-tuned and expanded and captured successful readings measuring from hours of data. From this, we were able to learn that the first stars were formed 180 million years after the Big Bang and brought the dark, unstable period of our early universe into what we know today. The first stars, born from hydrogen and helium after the cooling of the early universe, were massive, hot, and primarily emitted UV radiation. Their fusion processes over millions of years produced heavier elements, shaping the composition of the cosmos. Through meticulous analysis and research from astronomers and scientists, we continue to uncover the secrets of these ancient stars and illuminate the transformative journey to the universe that we recognize today.